Hello everyone. So in this tutorial, we're going to learn Pandas in action. Pandas is a Python library which is used for data analytics. It provides a high performance, easy to use data structures and tools for data analysis. It's very comprehensive, right, and that can be used for advanced data analysis. Okay. In this notebook, we're going to learn about the very essential and common functions, methods, and attributes or properties that you should know. And more importantly, we're going to learn how they are used. Okay, so of course, the number one thing we have to do is to import pandas. In pandas, there are two data structures which are very important, series and data frames. So series is very similar to Python's lists. It is a one-dimensional data structure that can store values, and you can use indexing to access, the values in a series. And this is how we initialize one. So it's a series pd.series, and we have the following numbers, and then this is the output. And series also come with a bunch of methods and functions, right? So if you want to, get a list of all the functions available to the series data structure, all you have to do is just type in the variable name, which is series, and then add a dot, and then press the tab key, right? So once you press the tab key, you have all this, right, arranged alphabetically. So from apps right down to XS. Okay, so you have all these things at your disposal. So the next data structure is data frame, which is very much normal like an Excel spreadsheet, which has rows and columns. Okay, and then we use the pd.dataframe function to create a data frame. Okay, and there are a number of ways of creating a data frame, and we shall go through each one of them. Okay, and so in this example, I used so I initialized the pd.dataframe, and then one of the parameters is columns, right, where you specify the column names in that, and then you have two square brackets, right, where in the inner brackets, the inner square bracket has, the rows, and then you have to arrange the items in the rows or in the inner bracket according to the columns, right? So in this one, the very first inner bracket, which spans from here to here, you can see that we have Sebastian, which corresponds to name. We have 24, which corresponds to age. We have Ghana, which corresponds to country, and Ashesi University, which corresponds to university. So you do the same thing for all of them, right? And then, you call the variable, and when you run the function, when you run it, you have this, right? Another way of doing the same thing is using dictionaries, right? In a Python dictionary, we have the key and then the value, right? Where the key represent the column names and then the value represent the rows, okay? So this time you have the name and then you have all the names, right? Over here, you had the name, the age, and all of that in one list, right? But over here, since you're using dictionaries, you have the key, which is the column name, and then you have all the names. You have the age, you have all the ages. You have the country, you have all the countries. You have the university, you have all the universities, okay? And then you're going to have the same outputs. Another way of doing the same thing is to initialize your data frame with the columns, okay, and then using the append method, you append it. So this time you also append it using a dictionary, right, where you have the name, key value pair, so the key, the name, the value Sebastian, the age, the country, the university, and so on and so forth. And then you don't have to forget to use the ignore index is equal to true, otherwise it's not going to work. So you do the same thing, and then you're going to have the same result. Alternatively, you can you can initialize a pd.data frame with the columns, and then using the lock property, which takes in the length of the data frame, which is essentially the length of the columns. In this case, the length of the column is 4, so it's going to run from 0 to 4, okay? And then you enter. So this time you name the content in the list should correspond with the columns, right? Where you have Sebastian to name, 24 to age, Ghana to country, and Ashesi University to university, okay? And then when you run it, you're going to have the same outputs, okay? So these are, I think, four ways of, you know, um, creating a data frame. Now we move on to loading a data set into Jupyter Notebook, okay? So we use the pd.readcsv function to, to load a data set into the Jupyter Notebook. So a parameter for the read CSV function is the name of the data set that you want to import into, or you want to load into the Python, into the Jupyter Notebook. Okay, so the name of our dataset is datasets credit scoring.csv, right? And when you run it, you have this. Okay. So we're going to move to data exploration. So data exploration is simply all the things that we do to get um, to understand the structure of our data set, right? To get to know the various columns we have, its data types, and so on and so forth, right? So all the things that we do to understand our data set, right? So one of them obviously is using the head function. The head function shows the first five rows of our data set, and if you enter a number into the head function, then it will return that number of rows, right? So in this case, we are saying credit score dot head 4, so it's going to return 4. If we say credit score dot head, let's say 10, it should return, 10 rows, and so on and so forth. Okay, so let's turn it back to 4, right? And then we have the tail. So the tail also shows the last 5 rows of our data set, right? You can also enter a number, to specify. For example, if you enter 10, it's going to return the last 10, rows in our data sets. Okay, so exactly that's what we have here. And then we also have the sample method. So the sample method just generates random rows, right? So the sample method takes in a number. If you don't enter any number, it's just going to return 1, right? 1 row, right? It's going to return 1 row. And anytime you run that cell, you're going to have different row, okay? So when you enter a number, let's say 5, you're going to have 5 random rows, okay? And the next thing is sorting, right? So sorting, so pandas allow us to sort values along either axis, so you can sort along the rows or along the columns, okay? And we use the sort values method to sort by a column or to sort by row. You have to also note, however, that you must set the in-place argument to true if you want the sorting to take effect on the data set. Else, you may have to create another variable to store the changes, right? So, in this cell, we are trying to sort by credit amount, okay? By credit amount. And so when we run that, we have it over here. So credit amount. So it's sorted from the smallest right down to the largest, okay? So this is one use of the sort value function. And then the next thing, we're going to go to summary, okay? So the shape property counts the number of rows and columns in the data set. The number of rows and columns can be specified by using the credit.score.shape. So if in the shape you put 0 in a square bracket, it means that you want to get the number of rows, and if you do 1, you're going to get a number of columns respectively. Okay, so when we did the credit score shape, we had 1,000 rows and 21 columns. Okay, and then we also have the info method. So the info method gives us a summary of our data set, right? All the columns, the number of non-null counts, and the data type, which is D type over here. So for example, the checking status has 979 non-null values, and then it is an object, right? If it's an int, it will be there. If it's a float, you would also see that, okay? And then we also have the describe method. So the describe method just also gives us, it generates descriptive statistics, right? And you also have to note that it excludes all null values, right? By default, it works on columns that are numerical, right? And so you have things like counts, you have the mean, you have the standard deviation, the mean, the minimum, how do you call it, the quartile range, the middle, the three quartile, and then the max. Okay, you have all these things over there. Um, yeah, and so it works only on columns that are numerical or that have numerical values. Okay, and if you want to include all the columns in the data set, you must use the all parameter. So in the described method, you one of the parameters will be include, and then in parentheses you write all, and then you're going to have all this. Right, good. Right, so the following functions are helpful in summarizing the data sets. By default, they do not include null values. You have to take into account. So the counts used to count the number of elements in each column. Right. Um, then there's a value count to get a frequency distribution of unique values. The number of unique, the n unique, which get the number of unique values, the mean, the standard deviation, the max, and then the minimum as well. So when you do credit score, which is the data set you're analyzing, dot count, you're going to get, it's going to count all the non-null values in each column, right? So that is what we have over here. And you can also count, you can also use the value count method on specific columns, right? So over here, we're using credit score housing, right? The housing column dot value counts. So in the housing column, we have the rents, and then the for free values, right? And the own value is 711. The rent is 179, and for free is 108. Okay. It also gives a data type, which is integer. And then we have the credit score, property magnitude. You can also check the number of unique values, which is 4. You can also check the mean for a particular column, the standard deviation, the max, and the minimum number as well. Okay. So now we go to selecting specific columns, right? So in analyzing your data, maybe you want to just have a look at specific columns. You can also do that. Okay, and this is how you do it. So in this cell, we have credit score, age, credit amount, and purpose. You also have to note that you have to use two square brackets, in order to return a data frame, right? If you use a single square bracket, if you use, a single square bracket, um, it's going to return a series object, and that can only take one column, right? So let me demonstrate that in action. So let's say I'm using credit score, and then I indicate, let's say, age, right? When I run that, it's going to return, a series objects, right? A series objects, not a data frame. But then if I add one more square brackets, then it's going to return a data frame, right? So you have to take note of that. You have to take note of that. Okay. So filtering for particular values, right? You can also filter your data sets, according to columns, right? And so in this cell, we are trying to filter the number of dependencies, right? So we are returning all number of, all rows which has number of dependencies on which has number of dependents greater than 1, right? And this is what our data, this is what this particular cell returned. And you can also, and this is a single column, right? You can also filter, our data. We can also filter our data set using multiple columns. Okay, so in this example, we are saying that credit score, which is age, the column age is greater than 40, and the class is good, and the housing is equal, and the value of the housing is own, right? And then you can also specify the columns that you want returned. Okay, so in this case, we're saying we want to return the credit history, the duration, the purpose, the installment, and the job. And this is what you have over here. Okay. And then you can also filter by rows and columns as well. Okay, so in this case, we're going to use the ilog property, right? The ilog property. So with the ilog property, it takes in the row and the column. So um, this, sorry, this is the row and this is the column. Okay, and so essentially what we're trying to say here is that we want the first 30 rows. Okay, and for the columns, we want the columns at index 4 to index 9, right? And this is what we have over here. Okay, and then we go to group by. Okay, so group by is used to aggregate data into groups to run calculations over each group. Okay, so what we are trying to do is that, so we are trying to group, you know, the job. We want to group our data sets by, job, right? And so when you look at what it returned in the job column, we have four unique values, which is the high quality, self-employed, management, unemployed, unskilled, non-residents, unskilled, resident, skilled, and so on and so forth. Okay, and so um, essentially what it is returning. So, for example, for the high qualified or self-employed value, it is 142 under the checking status, 148 under the duration, 148 under the credit history, and so on and so forth. For the unskilled, this is a number. For the unskilled resident too, this is the number. For the skilled, this is the number. Okay, and so if you want to see how, if you want to see for a particular column the count of each value across the other columns, you can use the group by method. Okay, and then you can also use the size method on it, just to see the counts as well. Okay, and you can also group by multiple columns. So in this case, we're grouping by job, class, and housing, and we're counting each of them, right? And this is what you have. So you have the high quality, and the high quality we want to look at the bad and good, and the bad we want to look at for free, own, and rent, and so on and so forth. Okay. And to make the above group by into a data frame, you can use the reset index method, right? So when you have all these things, and then you use the dot reset, and then you convert everything into a data frame, right? And then we come to data manipulation. So data manipulation is all the things that you do to add or to modify your data set, right? In order to prepare it for the next stage, which you can be modeling, prediction, and so on and so forth. Okay, right. And one of them is handling missing values. All right. For most data set, when you're working with some data set, there can be a lot of missing values, and you have to work with them, right? Usually, there are two ways, to handle missing values. Remove the rows and columns with missing values, impute missing values, replacing them with predefined values. Okay, and missing values in Python are denoted by NA null in Pandas, and then NA none, meaning not a number, in NumPy. Okay, and so in this cell, we're trying to, count the total number of null values in all the columns. Okay, and this is how we do it. And in the checking status, we have 21 null values, and so on and so forth. Okay, so let's check the shape of the data set before we drop the null value. So the shape of the data set is credit score dot shape, which is 1000 rows and 21 columns, right? So we're going to use a drop NA function to drop all the null values, all the rows with null values, okay? So when we did that, the rows reduced to 904, okay? And then we checked again to make sure that everything there are no null values, and you do that. Credit score NA is NA dot sum, and everything is 0, so which means there are no null values. Okay, right, so let's take a look at the own telephone column. Okay, so we counted, the values in the own telephone column, and then we checked the sum of the null values, which was 4. Okay, and so sometimes when you encounter null value, you may want to fill in that null value, right? And if you want to do that, you use the fill NA method, right? It takes in what you want to fill in, and then you set the in place to true to take effect. So when you do that, and then you count the values again, you realize that you have none, yes, and unknown, which is the new value that we've introduced. Okay, right, and so we want to confirm that. So when you look at the own value, you realize that the null values are 0 because we filled it. We filled the null values in the own telephone column. Okay, so handling irregular cardinality. So the cardinality is a different number of features we have to a particular feature, right? So for example, let's say you have a data set and you have a gender column, right? Gender is male or female, right? But then in your data set, maybe you have male, MALE, and you have female, the normal spelling. But in addition to those two, you can have M for male and F for female, right? The M and then the male, they are all the same, right? But then um, uh, the, in terms of strings, they are very different, and so pandas will treat it as different, and so we have to, find a way around that. Okay, all right. So when we take a look at the credit history column, we see 5 distinct values in that column. However, some of the unique values can be replaced with another. For example, the no credit all paid and existing paid means there is no obligation to make any payment since in each of the mentioned values, monies have been paid. Okay, so when you look at existing paid here, you look at all paid and no credits, essentially they mean paid. Okay, paid, right? And so there's no reason why they have to be separated, right? And so what we have to do is we have to use the replace method in the pandas to replace all these values with one value. And so we're replacing the all paid, no credit, all paid, existing paid with, we are replacing all these 3 values with the all paid, with this all paid, and then we set the in place to true. Okay, so one thing you can also see that we have double, quotes and single quote. This is because in the data set, the values are surrounded by single quotes, and so we have to, bring the double quote and then the single quote as well for it to run. Okay, and when we did that, we ran it and it worked. And so we have the credit history dot value counts. Realize that you have all paid over here. Okay, initially the all paid was 49, so when we added everything is now 618, so it worked. And then another thing you also do in the the data manipulation is to detect outliers. So outliers are values that significantly differ from other values in a column and they lie far away from the central tendency of a variable. The best way to visually detect outliers is to use box plot, right? And pandas allow for a direct visualization of a data frames column, right? And so we import matplotlib, which is going to help us to use the box plot function. Okay, so credit score dot box plot, the column we want is duration and age. Box plot allow us to visualize numerical and categorical variables. Okay, so you're trying to analyze the duration, we are trying to analyze the distribution of the duration and age. Okay, um, and so when we look at the graph, we see that there are some outliers. Okay, so these help us to know where the outliers are and take the necessary action. Okay, and another way of detecting outlier is to use the histogram function in matplotlib. Okay, so credit score dot hist, the column, duration, and then age. Okay, And when we plot it, you have this, right? And so it helps you to see if there are any outliers, okay? And then the last thing in this tutorial is saving a data frame. So after working on the data set, handling missing values, adding things and taking things out and so on and so forth, you would have prepared your data set for the next stage of the data science process, okay? And so you have to save your new data set. Right? And to save it is the credit score dot to CSV and then the name of the file. So I called it C underscore scores dot CSV. Index is equal to false. And when you do that and you run it, it saves in your folder where saves in the folder where the Jupyter notebook is located. Right. So at the end of this tutorial, you're going to have um, task, which is like assignment, which is supposed to help you to practice all that you've learned in Pandas. Okay, remember this is not all the functions. These are not all the functions in Pandas. It is just an introduction to some of the very important ones, very core ones, and basic ones that you should know as a data scientist. There are obviously more, and I've given references to where I modeled my tutorial after. So you have the pandas dot pydata.org, which is the documentation for pandas, and then future ranking as well. You can go there to learn more about pandas. And so there's going to be a task that we're going to share with you to help you practice more. Okay, all right. So catch you later on the next tutorial.